Hello, everyone, and welcome to our session on Zero Trust Security. My name is Sean Bass. I'm the CTO for End User Computing at VMware, and I'm joined here with my colleague Perry from the Networking and Security Business Unit at VMware. This session is going to be all about Zero Trust best practices. We're not going to be talking about products necessarily. We're talking about the principles behind enabling Zero Trust security that you can apply in your organization. And moreover, how you should be thinking about Zero Trust security, not in a silo or piece parts, but how all the connective tissue comes together to achieve Zero Trust in the enterprise. So with that, I want to talk a little bit about how things have changed in the history of application architectures and cloud computing and networks and all these types of things. So I think it's really important for us to first identify what's been changing with how technology works in order for us to understand how we need to be thinking about defense in a slightly different way. So the first thing I'd like to say is, in a traditional three-tier application architecture, we used to protect these with typical north-south firewalls, and we'd apply security in the workload, and we think about it in a pretty simplistic way. But over time, application architectures have changed dramatically. We've gone from simple three-tier application architectures that are contained inside singular servers. We've moved into microservices, multi-VM architectures, containers, and this has created a lot more opportunity for there to be security vulnerabilities in all the different piece parts of the application architecture. In addition, when we think about the data center itself, we used to just have a single data center to worry about protecting the four walls of the data center. And over time, of course, that has now exploded out into multiple different public clouds, enabling hybrid cloud connectivity. And this has, of course, resulted in more opportunity for application infrastructure and data to be exposed and exploited in multiple different places. In addition, when we think about how people connect in to our data center and cloud applications, the architecture of the traditional branch office has changed quite dramatically. We've moved from a traditional corporate office and branch office scenario to really this distributed workforce where we have multimodal work styles. We've got people working on corporate devices, personal devices. There's this whole new market of the gig economy where people might be working for multiple different companies on different types of assets. And that's really created a new set of challenges around how we secure our applications and data in these different modes of work styles. And so really, where there was possibly a perimeter in the past that we could worry about defending the four walls, that perimeter is completely dissolved. We really have to be thinking about this new modern shape of digital business and applying security everywhere that our applications and data reside. So when we think about that, what we've really done with all these changes to the application architecture and data center and branch offices is that we've really introduced this attack surface explosion. There are opportunities to exploit end users and their identity through phishing attacks and credential theft. We've got opportunities to attack the endpoints both at the edge the end user is using as well as in the cloud and in the data center. And of course, there's misconfigurations in cloud applications. You read in the news all the time about companies who have misconfigured permissions on their data storage that then data gets stolen from those misconfigurations. So there are lots of opportunities to increase security, but equally an increased number of opportunities for attackers to exploit. And I'd like to touch on as well, since COVID-19, we've seen all this workforce move from being in the office to now working from home. And that's resulted in a significant amount of increases of attacks on remote access infrastructure like classic VPNs, as well as attackers that are trying to attack the home workers' devices and then using those as pivot points into the corporate network. So it's really given us a lot to think about how we need a new approach to security. And that new approach is really how we can think about utilizing the concepts of zero trust to secure this distributed enterprise. And zero trust is really a way for us to think about all those different attack points. What can I do to drive a better level of security in order to understand, rather than assuming I have implicit trust of an endpoint device and implicit trust of a corporate network, I need ways to be able to validate, is this device actually as trustworthy as I think it is? Is the user who they say they are? Can they prove their identity to my infrastructure? What level of access should I grant to my end users? How do I protect my data? How do I give granular, restricted access to my applications and data in my data center or cloud? And how do I prevent lateral movement of an attacker if they do happen to compromise one of these attack points? And so we really need to start thinking about this picture holistically and recognize that there are opportunities to apply levels of security controls at each and every one of these pieces of the infrastructure. And while I can view each one of these attack vectors as an individual island of security, when I start thinking about how the context of all of these points adds up as an attack unfolds, that gives me a much greater ability to pinpoint an attack as it unfolds. So having the ability to look at the data contextually from one point to the next, how is the end user device being used? What identity are they authenticating with? What network transport are they going across, and what security can I apply there? And then what application backend are they talking to? And how can I apply security controls at every level to give me a more holistic view of the end user as they progress through the data center and cloud application architecture? So we need to be thinking about this in a distributed sense, and we need to be thinking about how we can correlate activities at each one of these control points to improve the overall security posture. And while we're not going to talk about products specifically, I do want to talk about areas of focus for Zero Trust that we need to be thinking about. Zero Trust is all about end-to-end visibility and analytics, and most importantly, the ability to automate and orchestrate response across these different dimensions. And a lot of times when you think about Zero Trust security, people tend to take a very user identity-centric point of view, that it's all about identity conditional access and endpoint device posture. But I think if we only focus on the end user device and the end user identity, we miss an entire portion of the Zero Trust puzzle, where we think about the network transport that connects the user to the applications in the data center or cloud, and then what happens within the data center and cloud to further enhance and secure the principles in the application architecture itself. And having the ability to tie the end user identity as a common thread all the way through these 4 different stacks really gives us a lot of capability to link activities of the user into the data center and cloud. That gives us much better visibility and gives us more context about the type of behaviors that are normal and the type of behaviors that are abnormal. And that allows us to then further secure and protect these resources. So I'd like to take a brief moment to kind of talk about what an end-to-end Zero Trust architecture looks like in terms of all of the piece parts that make it up. And to do so, I want to bring my colleague Perry in to talk about a Zero Trust architecture from an end-to-end point of view and all the piece parts that come into that. Perry, please join me.
Thanks, Sean. And as you can see, based on what Sean is explaining, there's a lot to unpack on Zero Trust. I mean, we are talking about how do we transform the security models going from an endpoint to an application to how the network reacts. So there's multiple layers that we have to uncover. As Sean was mentioning, everything starts by identity. And if you think right now, we have a model where identity is understood in 2 dimensions. One, on the user side, where we understand the identity of the user and the attributes associated to the user. The other, we are going to discuss about the identity of applications and how applications, from IP addresses to labels to certificates to names, how identity is a fundamental concept of this end-to-end strategy. Now, as we focus on provisioning those applications of those users in the network, then there's the multiple layers of enforcement. And as Sean was mentioning, in this end-to-end approach, basically the perimeters have completely disappeared, and now we are living in this notion of decentralized and fully scale-out enforcement. This is where essentially the Zero Trust architecture has to go where the user is, where the application is. And as you can see in the picture, starting from the bottom layers of how do we connect end-to-end from an internet connectivity point of view, or how do we go up the stack from an encryption or authentication authorization at the API level, the perimeter essentially has been decomposed into this end-to-end model that has to run essentially anywhere. Anywhere meaning from, on the left side, any device, any home, any office, any place where an application, when a user may want to connect. And on the right side, essentially any cloud, private or public, where applications may live in any form factor. Now, that's all good, but in some cases, it's not completely possible. And this is where, for example, in cases of IoT or thin devices or bring your own device, certain capabilities may not be possible because of power consumption or CPUs and so on. And this is where then there is a strategy of where do you put this distributed enforcement point? And there's always a strategy to put it based on the endpoints or in points of presence in the network. And this is what we are seeing is from a zero trust point of view, a proliferation of this bimodal wall where we have these enforcement points at the endpoints of the application as well as in the pod in the network. But going to what Sean was mentioning, the architecture is not complete by not understanding the end-to-end posture of devices, users, applications, and how they behave and how they essentially move from understanding the policy aspect to more a subtle understanding of risk management. And this is where we go towards the analytics plane. So it's not enough to understand identity and enforcement. And now we have to focus on understanding how all the analytics essentially that get collected in a holistic way to understand what's our overall risk posture of this end-to-end architecture. And as you can see, this is a space that traditionally has been done by multiple solutions, components, products, and so on. And openness and a third-party integration framework is very important to essentially deliver these end-to-end architectures. Maybe Sean, back to you.
Thank you, Perry. So Perry talked about what an end-to-end solution might look like, and there's a lot of technologies and products that make that up. And I want to maybe spend a little bit of time deep diving into the end user space where my business spends most of our time and talk about, what are the constructs of user identity and device security that are utilized as inputs into a zero trust architecture. So when we talk user identity, of course, we're talking about things like authentication and authorization and user behavior and multi-factor authentication, single sign-on, all of those types of concepts. And then from a device security point of view, we've got to think about, how do we ensure that this device is secure? How can it be determined if it's trusted and whether it's compliant with corporate security policies? So what I'd like to do is dig a little bit into what the goal is around end user device and end user identity attestation or trust. At the end of the day, our goal is to make sure that all of our users can access the critical applications and data that they need to do their job from any device they happen to have in their possession. It shouldn't matter if it's a Windows device, a Mac device, an Android device. The device they use should be irrelevant. What we really need to do is make sure that we can trust that level of access by doing some form of device compliance or device posture attestation. And then through a layered defense approach, how can we ensure that this device and user combination is secure for the right level of application access? So when we think about device compliance, this is things that, a lot of different products do this in different ways, but the end goal is to make sure that this device seems trustworthy. Now, every company will have different levels of compliance rules, what they deem trustworthy or not. But some of the common things we see people look for is, what operating system is this device running? Is it an operating system that's been produced by the vendor within the last, 6 to 12 months? Because if the device is 2 years out of date in operating system standards, maybe that's a criteria for us to say, I'm sorry, your device is not acceptable to access our applications and data. Likewise, you might use other things like the patch status. Is this thing missing critical security vulnerabilities that are being actively exploited in the wild? And I might want to consider this device not trustworthy enough. It may be things like, is the device have a firewall enabled? Is it have disk encryption? And all of these things will enter into the policy that your company needs to set to define what do you deem as a trustworthy device. So outside the device compliance, we also have to think about things like identity and access management. This is typically where things like conditional access, single sign-on, identity federation, multi-factor authentication come into play. So this is me proving that the user is who they say they are, and I've not had a credential theft or somebody impersonating my user, that I have mechanisms to prove that they are in fact who they say they are. This can also come through in some cases, not just traditional multi-factor authentication with a token mechanism, but it may be utilizing hardware security keys to enforce that this is in fact the user in possession of those devices. And then that identity and access policy may also vary based on the criticality of the application I'm exposing. For instance, I may not care that much if somebody signs into my time card system and enters in their hours if their endpoint device is deemed a little bit risky. I may care dearly if they're trying to access an HR system or a financial system. So the level of criticality of the application and data should enter into your zero trust criteria. Now, how they get to applications, particularly those that are located in your private cloud or in a public cloud resource, we need to be thinking about how we ensure the transport of that data. And what a lot of organizations are doing as part of their zero trust journey is saying, can I move away from device-based VPN solutions that transmit all of the network traffic of my end user devices to my data center or cloud resources, and can I move to more of a granular per app tunnel or kind of a microsegment of one to reduce the risk that if one of these devices does become compromised, I'm not risking the integrity of my corporate data center or my cloud applications and resources. I want to speak a bit about risk analytics as well. You know, we can enforce a certain level of device compliance, but we always want to be on the lookout for behavioral changes with the device or with the user identity to reflect a potential thing we might have to change our level of response based on it. So one example of this could be a user's identity starts getting brute forced login attempts against it. I might want to raise the risk level for that user and treat them differently. Maybe provide some additional challenge responses to prove they are who they say they are. Or if a particular endpoint device looks risky because of the presence of some software, whether it's malware or remote access Trojan, I might want to disqualify that device from having access to different applications in my environment until that device can be brought into remediation. Now, while we're speaking about remediation, it's really important that we have ways of responding to risk conditions on devices. Those responses could be something as simple as notifying the user you can't use this device to access the resources, or it may be a notification to the user that says, in order to access these resources, you have to take this action if it's a BYOD device. You need to turn your firewall on, you need to update your security patches or your OS. Or if it's a solution or an endpoint device the company manages, you may just go take those remediations automatically by updating the software, applying the patches, enabling the firewall, things of that nature. And then the last thing I'd like to say is, zero trust cannot be done by one entity or one vendor. It's really a team sport that needs to be done through multiple different layers of technology that may come from multiple different vendors. So we always got to be thinking about the interoperability of the security ecosystem. How can we get threat data from our endpoint protection vendor or our cloud access security broker or a mobile threat defense vendor, ingest that threat data, and then use that to drive automated remediations or automated notifications to different teams to then respond to those security events accordingly. And then I think the last thing I want to talk about is, what do we need to be thinking about when we think about device compliance and conditional access to resources? And this is just a smattering of different examples that you might use in your qualifications of how you define your zero trust access policies. And I'll just pick on a couple here to talk about. If I think about, users, what group memberships are they part of? What things do they have access to? Should I treat every user the same way? Whether it's the CEO of the company or a software developer, I may need to have different granular policies based on the role and responsibility of that user or what groups they're a member of. I may look at things like risk factors on devices. If a device is a bring your own device situation, maybe I want to give a restricted set of access to a virtual application instance or only browser-based applications and not give them access to native application experiences if I don't have a good way of controlling the DLP or security controls around the data that resides on that device. You also might want to think about things like location, whether somebody's on a corporate Wi-Fi or off a corporate Wi-Fi. We see a lot of examples in retail or healthcare where certain applications may be permitted when you're on that secure wireless environment. The minute you move off of it, there might be a requirement to remove access to those applications or remove a subset of data or apps from a device because it's deemed risky. Or people traveling to certain regions, you might want to lock out certain applications when they're in certain countries or regions that you don't trust that those devices are not potentially being compromised. So all of these criteria around both device posture or device attestation and conditional access are all factors you should be thinking about when you craft your zero trust policies, and be conscious of the opportunities that it provides you to have an additional set of security controls that you can apply to a user and a device as they enter your zero trust architecture. Now, what I'd like to do is turn it over to my colleague, Perry, to spend a little bit more time talking about the network transport and the data center and cloud network controls, and what we can do from an app and workload security level and how all that comes together. So Perry, over to you.
So thanks, Sean. And as Sean was mentioning, now we are going to switch at the network aspect of Zero Trust. And this is going to be the element of where we can do a lot of enforcement capabilities, and we'll cover how the network and the endpoint are part of this architecture. So first, let's analyze why the current network strategies are not working. And if you think in terms of the traditional techniques, in terms of how to connect from a device to the network, a lot of times we tend to use VPN technologies. Now, apart from VPNs, we have firewalls and we have like IPS devices, and now we have cloud and multi-cloud. And what became obvious was that essentially this heterogeneity of environments and products that we had within our networks created a lot of silos, a lot of operational points, and lack of visibility. Now, if we factor that the fact that we are trying to accelerate innovation in our enterprises, bring agility, bring application modernization with CI/CD pipelines and GitOps, essentially transforming the way we deliver value, those technologies are no longer feasible. We cannot anymore set up a VPN to connect two clouds together before a developer can deploy an automated pipeline and things like that. So now when we start thinking in terms of how the network has to change to provide security models, we have to figure out not only the controls and policy enforcement points and capabilities that we traditionally have thought that we need, but we have to think in terms of how that value gets delivered, in terms of management, in terms of operations, in terms of end-to-end visibility. And if we go back to the current model of fragmentation, multiple products, multiple controls, all these things are getting into our way of automation and agility and security. So let's explore what we can do or what we see in terms of Zero Trust architectures to improve on those problems. Now, from a connectivity point of view, from a networking point of view, there's always two sides of the equation. The first one is going to be where the users are, and the second is going to be where the application lives and how we bring the two together. So let's focus first on where the users are. And as Sean was mentioning, there's a lot to unpack on the users. There's a lot of the aspects of user behavior, user identity, device management, device posture. But the first thing from a networking point of view that comes to bear is how do I provide a consistent experience between users anywhere they are? And by users, we mean, for example, you have a branch office, you have an industrial floor, you have a person working from home or somebody working from a device in a remote location. So the first thing that we have to bring into this network connectivity or consistent network connectivity is this notion of this secure trust, zero trust network access. And how do we bring homogeneity between what we see in the branches and homes with what we see in the devices? And this is what we achieve with this type of technologies of SD-WAN, secure access, and how do we bring consistency into the form of POPs in the network, points of presence. Now, the good thing about introducing these points of presence is that essentially allows us to normalize the access that you get from all those devices, regardless of what flavor and what location they come from. Now that we have normalized that, we can essentially start thinking in terms of how to bring security capabilities into those POPs. Now, if you think it's not just bringing security capabilities because we are used to that, it's because now as the traffic flows through this network, we want to avoid hairpinning. Essentially, we want to avoid latency problems, networking problems. So bringing all the solution together in this zero trust POP architecture allows us essentially to provide the most efficient and easy to pack security and connectivity solution. Now, as we discussed, it's not just about the enforcement point, it's about the visibility, it's about the aspects of troubleshooting when a system doesn't work, it's understanding user behavior, it's understanding traffic flows and changes into our patterns. And this is what we achieve essentially by putting a monitoring solution that comes together on all these elements. Now, the third aspect is this notion of how do we manage that? Do we offer it as a service, a collection of products? And the more we go towards zero trust architectures, we tend to see that the manageability aspect, the service aspect of this solution is primordial to provide a proper agile environment. So this is where we see the notion of the security and connectivity converging into these environments. Now, at the same time, these POPs are not just useful to bring consistency into the users, but we see a lot of new innovations and a lot of interesting things happening into the multi-cloud connectivity. Now, multi-cloud connectivity, again, has two components, the networking and the security. And the security becomes this notion of how to normalize across the onboarding and offboarding of all these clouds. And this is another area that a lot of opportunities on these zero trust SASE POP architectures. Now, if we try to bring it together, essentially what we are seeing is that we have to provide this end-to-end thinking that Sean was talking about before. We have to bring this aspect of a secure solution that regardless of where the devices are and the applications are, we provide end-to-end across any location security. Now, the part to emphasize though is that we cannot provide security without identity. And now as we get into these identity systems, we bring the fact that when borders and boundaries have disappeared, we have to start thinking how the network changes from, let's say, end-to-end encryption or end-to-end inspection and so on. So this is where identity is going to be one of the pillars of this zero trust transformation. And it has lots of implications on how we design and how we factor the network into this solution. The second aspect is policy. As Sean was mentioning, there's many forms of policy. We could start thinking that now with all the things that we can gather from the network, from the endpoints, from the devices, we can start thinking in terms of forms of attribute-based access control and essentially provide very fine granular control points in an end-to-end fashion. But as we discussed, we have to start thinking in terms of risk and risk management. The network is becoming so broad and so extended across, let's say, the whole geography where applications and users live, that now we have to start thinking how policy and risk management start to play together and how the network's enforcement point essentially can start operating not only based on declarative and formally defined policies that have essentially a black and white behavior. Now we start thinking in terms of more, what's the impact if this security incident would happen into our environments? And how do we start bringing these risk controls and the end-to-end understanding into how the network essentially helps prevent or detect some of that? And as we start shifting towards the right, we arrive to the multi-cloud. And this takes us to the second part of this zero trust networking discussion, which is when we start seeing how the applications that live in these multi-cloud environments, they have to start thinking in terms of how this heterogeneous ecosystem of clouds that we are creating, how do we bring some sort of security controls that homogenize the understanding, the monitoring, the security capabilities. And the first obvious thing, essentially, as we double-click into the application side, is that the notion of perimeters is not sufficient. Traditionally, we thought security from a networking point of view by putting boundaries and perimeters and firewalls and so on. But as we go to zero trust models and multi-cloud models, there's no perimeters anymore. And now we have to take the perimeter all the way close to the application. This is where we start thinking in terms of east-west traffic and zero trust security models with east-west traffic to prevent lateral movements and attacks that may happen once one of our applications is compromised. Now, if you think like that, the whole strategy starts by a proper segmentation east-west capability that allows us essentially to compartmentalize how the applications see each other. Now, there's no trust anymore from anybody to anybody, as in an east-west model with segmentation. We try to understand based on the identity and the capabilities and the function of the applications, what needs do they have to interact with everybody else. The second, as we get into this per application microsegmentation, we start understanding much more about the application. And it's not just IP addresses or connectivity models from an infrastructure point of view, but we start understanding what applications are, what application patterns are, what's normal in terms of how application connectivity graph gets developed and so on. And we provide customized microsegmentation experience for those applications. Now, as we go up the stack, we start getting into the content and understanding essentially what's going on at the layer 7 level. And this is what we get in terms of intrusion detection capabilities, anomaly detection, web application firewalls, and we start providing like inline east-west capabilities of understanding what the application is doing at level 7. This allows us to do a lot of things in terms of preventing vulnerabilities that have been discovered and stopping them as we see the traffic trying to exercise them. We can essentially customize the set of controls that we want to offer at level 7 based on the function and criticality of the application and so on. And as we go one level high, essentially we start thinking in terms of how do we detect patterns that are not acceptable or that are exposing certain amount of risk, and how do we respond to that? And we get into the network detection and response. So all this essentially has to work as a system. The network is no longer a set of layers disconnected that we have to essentially manage and control and configure at each level of the stack, but it has to kind of obey to the zero trust principles on how do we go in an end-to-end understanding of how the connectivities and behaviors are happening. Now, as we stay on the application side, one aspect is the network. How do we essentially control and discover and connect all the things that are going on? But since we are in the endpoint, there's another thing that we can consider from a zero trust architecture, and this the endpoint element. Now, as we have essentially the ability to understand and see what happens in the endpoint, now we go from what we could do from a zero trust east-west distributed network architecture to essentially having a full understanding of what the endpoint is doing, what system calls are happening, what kind of processes are running, are the processes being tampered, what files are being touched. And this is this notion that now we can identify risk and understand vulnerabilities in the application itself, or understand changes of behavior in the application itself. Now, this allows us to essentially provide a very fine-grained and very understood level of how application is performing, and get into the notion of understanding, detecting, and responding real time to what's happening into the application and into the data center or cloud. And this allows us essentially to create preventing systems that, as we tie the behavior of the endpoint, what we see in the endpoint itself, with what we see in the network, with what we see at the user and device level, now we can create not only posture on a component by component basis, which is important, but a full understanding of the security capabilities end to end. And this takes us back to the risk discussion that we had just a few minutes before. Once we understand all the elements in a more holistic way, now we can think in terms of risk. So if we go back to kind of the big picture and we try to summarize, when we go to these end-to-end zero trust architectures, it's not any longer about understanding security in silos or understanding security in different stages of your environment, like cloud versus on-prem versus devices versus network, but rather how do we understand in a holistic manner that end-to-end, what are connectivity patterns, what are user behaviors, what are device postures, what are application behaviors, and how they interpret between themselves. And this is where essentially starting by identity, as mentioned, and understanding device and endpoint state, we can essentially gather a lot of intelligence to create a posture of devices, users, applications, and have this behavioral understanding that allows us to think in terms of risk. Now, if we take it at the bottom part of the picture, how do we then try to insert the right knobs, the right points of enforcement that we can essentially render the system secure, starting by the device and putting the right elements in the device that we can understand the vulnerabilities, the behavior, and so on, but taking it all the way to the network, being points of presence in the network to intercept and create a system of homogeneity in terms of access and security, or going all the way to the multi-cloud and understanding all the east-west communication patterns. So in summary, end-to-end is the kind of fundamental aspect of understanding zero trust and understanding not only the connectivity patterns, but the identity and behavioral patterns, and putting everything together in a much more holistic way that we can understand risk. Now, when we do these transitions, it's never easy. As Sean was mentioning before, we've gone from managing lots of individual components from a security point of view to now look at these architectures that take a much more comprehensive and holistic nature. But there's a path along the way. That's why zero trust and the end-to-end architecture is a good direction where we are going as an industry. But at the same time, it's going to be built across a lot of interactions, integrations, standard interfaces, interoperability, because we have to build a system and an ecosystem that essentially plays towards this end direction that we are solving in a more holistic way. So with this, I just wanted to thank all of you for your time on behalf of Sean and me, and essentially ask for feedback and participation on this journey, because this is going to be a very interesting change in the industry where we start thinking in terms of security and connectivity as a much more systematic way end-to-end rather than side-by-side. And we are going to essentially, through this journey, enable organizations to become more secure, more agile, to essentially be competitive in the current landscape. Thank you again.